Mm. Okay. So, in our last class, we were discussing about 1,4 dithiate. Okay, let's take a pointer. Okay. So, in our last class, we were discussing about the dithiocins. Okay. More particularly, we were discussing about the 1,4 dithiocins. This 1,4 dithiocin we can prepare starting with a bicyclic compound. So this bicyclic compound on heating ring opening reactions and forming a 1,4 dithiocin. So how it will open? This double bond or bonded pair is coming over here, and this will go over here. That is how ring opens takes place. So this is one method of preparation of dithiocin. So with this, I will go to the next slide. Okay. So here one more method is mentioned. More particularly, you can observe that. So two thio groups are there. Okay. So and one more this ethylene group. Okay. These two carbon is called ethylene carbon, and it's a protected one. More particularly, a dihal is protected with acetone. So then what is called with respect to ketone, it's a ketol. Okay, otherwise hydroxy protected one. So what we can say that hydroxythiol. Okay, hydroxythiol when it is heated with vinyl chloride. Okay, this group is called vinyl group. Okay, otherwise even we can call it as a ethene. Okay, ethene dichloride. So what will happen? A lone pair can attack here, or even bond pair can attack here, and Cl will go out. Similarly, lone pair or bond pair can attack, and Cl will go out, forming a 8-membered ring. So then cleavage of this ketol. Okay, what will happen? There will be a cleavage. How it will cleavage? Lone pair present on the oxygen can capture a proton, and there will be a cleavage. Okay, so the obtained ones are here acetone group. Okay, CH3CO CH3. Acetone is the living group, and the obtained product is a diol. More particularly, it's called vicinal diol. Vicinal means adjacent carbon containing hydroxy groups. Okay, so this diol is again protected. Okay, this also a protecting group. The name of this compound is called a tosyl group. Tosyl group means para-toluene sulfonyl chloride. TS chloride means para-toluene sulfonyl chloride. What will happen? Two molecule of para-toluene sulfonyl chloride is treated with glycol or vicinal diol. So removal of two molecule of HCl, and the obtained ones are called tosylate. This is tosyl chloride, and this is a tosylate. So again, the obtained tosylate, when it is treated with potassium tertiary butoxide. Potassium tertiary butoxide is a base, so it can obstruct this proton. Then what is the leaving group? Leaving group is tertiary butanol. Tertiary butanol is a solvent. Okay, so then after formation of anion, this bond pair can come over here, and this will go out. And what is the leaving group again here? So in addition to the tertiary butanol, there is also a para-toluene sulfonic acid, PTSA. Okay, so that so here TSO and this can picks up this proton. That means para-toluene sulfonic acid is the byproduct, and tertiary butanol also byproduct. And what is the forming product? Here there is a new double bond, so that is a new double bond. And then cleavage, okay, deprotection of tosylate group. So it is possible when it is treated with acid source. Acid source may be a HCl in water, HCl in sulfuric acid in water, or acetic acid can cleave this O sulfonyl group. So the obtained one is an alcohol. And you know that primary alcohol on oxidation gives aldehyde. Similarly, secondary alcohol on oxidation gives ketone. So here what is happening? Dehydrogenation, removal of H2. So any dehydrating agent can be used. For example, DDT can be used to convert a secondary alcohol into tertiary alcohol. So the obtained one is tertiary alcohol. And this tertiary alcohol in presence of acetyl chloride, what will happen? The lone, what is that? There is, this proton is acidic. You know that. Why? Because this proton is acidic because it is adjacent to the carbonyl group. And this proton called enolic carbon, or what will happen? The proton can be easily captured. So what captured means H and Cl will go out as HCl as a byproduct, and the bond pair can come over here, and this bond pair picks up this acetyl group. So I think you what is that? Keto-enol tautomerism. Okay, this ketone will be equilibrium with the enol form. Okay, that enol form react with acetyl chloride. HCl is going out, and the product formed is acetoxy. So acetoxy, 6 acetoxy, 1, 2, 3, 4, 5, 6, 6 acetoxy, 1,4 dithiocin. Okay, this is how a 6 acetoxy 1,4 dithiocin is obtained. So with this, I will go to the next method of preparation of dithiocin. So here I am taking one compound. You know that 1, 2. Okay, 1, 2 dichloro, and this is 3, 3, 4, 4 tetrafluoro cyclobutene. Okay, 1, 2 dichloro, 3, 3, 4, 4 tetrafluoro cyclobutene. So 3 molecule of 1, 2 dichloro tetrafluorocyclobutene. This is one, this is one more, this is one more. So 3 molecules react with sulfur chloride, SCl2. Okay, sulfur chloride. What will happen? There will be, so this reaction occurs in presence of a strong base called N-butyl lithium. So what is the leaving group? Leaving group is lithium chloride. So lithium chloride will go out. So then there will be a bond formation. How the bond formation? There will be a bond formation between this sulfur and this carbon. Similarly, between this sulfur and this carbon. So similarly, there will be a new bond formation between this carbon and this carbon, and this carbon and this sulfur and this carbon. So it is possible in presence of a base called N-butyl lithium. Okay, it's a liquid. More particularly, the molar 1.6 molar solution is available in hexane. Okay, it's moisture sensitive. It should be one should not like open a lived in a bottle. Okay, we should pass. Okay, just by giving the pressure to that bottle, the solution should pass from one container to other. Okay, just like how the gaseous material can be passed. No, in that way, this solution should be pass. That means one should carry out this reaction under argon atmosphere or nitrogen atmosphere, since it is a moisture sensitive. So the obtained compound is 1,4 dithiocin. So then with this, I will go to, this is about more particularly what is called as dithiocin. Okay, so up to this we discussed about a 3-membered ring, 4-membered ring, 6-membered ring, okay, and also a 7-membered ring, and then 8-membered ring also. So more particularly up to this we discussed about the heterocycle containing nitrogen, heterocycle containing oxygen, heterocycle containing sulfur as the heteroatom. But maybe now onwards we will discuss about the heterocycles containing other than carbon, other than sulfur, oxygen, and nitrogen. So let's look into that. So you know that heterocycles containing phosphorus, heterocycles containing phosphorus, heterocycle containing arsenic, heterocycle containing antimony, okay, heterocycle containing boron. Okay, so as per our syllabus we are not discussing about the boron, but we are discussing about the heterocycle containing phosphorus, arsenic, and antimony. So let's look into the 5-membered phosphorus heterocycle. So 5-membered phosphorus heterocycle means this is one. Okay, phosphorylane. Okay, here what you need to remember that LANE. Okay, LANE indicates that it's a saturated one. There is no double bond. Okay, LANE, it indicates that there is no double bond. And then here phospholate, this also a phospholate. Why? Because LANE, phospholate, because there is no double bond. And thus there is a substituent at one position, 1-phenyl phosphorylane. So then what is the name of this compound? One, this position is 1, since it is a heteroatom, and there is a oxo. If you want to mention oxygen as a substituent, you have to say that oxo. So 1 oxo, 1 phenyl. Okay, this you have to correct it. This is not a methyl group. Maybe you need to. This is a phenyl. Okay, so this is a phenyl group. Right. So this is phenyl, one oxo, 1 phenyl phosphorylane. So similarly, there is a double bond you can observe. So that is the reason the suffix is ene. Okay. So then what we can say that phospholine. Okay. And if there is a 2 double bond, I think you know that azole. Azole, what is azole? A 5-membered ring with nitrogen, 2 nitrogen. Okay, not only 2 nitrogen containing 5-membered ring with 2 double bonds is called azoles. The maybe pyrazole, imidazole, isoxazole, oxazole, all those things. Similarly, here also OLE. In azole also OLE is the suffix. Since it is a 5-membered ring, OLE is the suffix. And what is the prefix for phosphorus containing one? Phospho. Phospho is the prefix for phosphorus containing heterocycle. So then these are the few 5-membered phosphorus containing heterocycle. So we will look into the preparation, how one can prepare. So here I am taking a 4-membered. This is 1, 2, 3, 4. So what we can say that 1,4 dibromo, 1,4 dibromobutane, 1,4 dibromobutane when it is treated with magnesium. Magnesium is a metal, what will happen? There will be a formation of organometallic compound. Okay, organometallic compound is magnesium bromide. So this magnesium bromide, you know that this organometallic bromides are organometallic Grignard reaction. More particularly, name of this is one example of Grignard reaction. What will happen? So this also you need to carry out in a argon atmosphere, not just like opening the flask towards the atmosphere. So what will happen here? This attains a negative anionic nature. So now this carbon is a electrophilic in nature. So when this carbon is attacked by magnesium bromide, then this carbon attains a nucleophilic in nature. Now this bonded pair can attack the electron deficient phosphorus and chlorine will go out. Similarly, this bond pair will attack here, Cl will go out. So here what is the living group? The living group is magnesium dichloride. And what is the name of this compound? So in this compound, you can observe that 2 chloro is there, dichlorophenyl phosphine. So name of this compound is called dichlorophenyl phosphine. So what it means? It means that a Grignard reagent, okay, more particularly 1,4 butane magnesium bromide, dimagnesium bromide, when it is treated with dichlorophenyl phosphine, it gives phenyl, 1-phenyl phosphorane. Okay, so this 1-phenyl phosphorane, when it is oxidized, okay, when it is oxidized with the oxidizing agent, here the oxidizing agent is N2O4. So then the obtained compound is 1-oxo 1-phenyl phosphorane. Okay, 1-oxo 1-phenyl phosphorane. So this is how 1-oxo 1-phenyl phosphorane is obtained, starting with the 1,4 dibromo compound when it is treated with magnesium, followed by treating with dichlorophenyl phosphine, and the obtained compound is oxidized to get 1-oxo 1-phenyl phosphorane. So one more method also we can look into that. Here the reactant is same, 1,4 dibromo butane is same, but one more reactant. Instead of going for magnesium, one can take the diphenyl. Okay, otherwise this is di, here also di, means tetraphenyl by diphosphine. Okay, tetraphenyl diphosphine, when it is treated with 1,4 butane dibromide, what will happen? There will be a product formation like this. So how the product formation? The lone pair present on the phosphor can react with this carbon and Br. Okay, so in this situation, what is the Br role? Br will act as a neutralizing anion. It's something like just like a salt formation. Okay, there will be a new bond formation between this phosphorus and this carbon, and Br minus will here as a counter anion. So then what will happen? Once there is a use of lone pair in the bond formation, this bond weaks. So you know that Br minus already is there. That Br minus form a bond with this phosphorus, and this bond pair will go over and convert as a lone pair. So that is what the product is obtained. So again, what will happen? Intramolecular cyclization. So the lone pair present on the phosphorus can attack this carbon and Br will go out. So that is how the product is obtained. So you know that since there is a use of lone pair present on the phosphorus, that is the reason positive charge here. At this moment, so when you are quenching with the water, OH minus or water can attack this phosphorus and forming a compound like this. And later stage, the lone pair or the bond pair can attack here and phenyl will go out. And here the living group is phenol. Okay, and the obtained compound is 1-oxo 1-phenyl phosphorane. 1-oxo 1-phenyl phosphorane is the product. It is obtained when 1,4 butane dibromide is treated with the tetraphenyl uh, diphosphine. Okay, yeah, that's all. Uh, so here the two reactant, these two are the reactant, and this is the product. That's all. Okay. So this is one more method of preparation of 1-oxo 1-phenyl phosphorane. Okay. So these are the two methods for the preparation of 1-oxo 1-phenyl phosphorane. So with this, I will go to the next slide. Okay, I will go for a next slide. Right, now it will come. Right. So phospholine means, suppose if you want to prepare a double bond containing one, okay, and here you need to change it. This is not phospholine, it should be phospholine. Okay, I will change here itself. This is a E. Okay, you can mention it as a, okay, E. You can change it as a E. So then what will happen here? So here the reactants, you just look into the one reactant is called butadiene, another reactant is dichloro phenyl. Okay, dichlorophenyl phosphine. So dichlorophenyl phosphine, when it is treated with 1,3 butadiene, it is something like polar addition. I think you come across this type of reactions in pericyclic reaction itself. So what is happening? Of course, this bond pair is going over here, and this bond pair will form a new bond with phosphine. Similarly, lone pair present on the phosphine can form a bond with this carbon. So that is how a compound is formed. So later, what will happen? OH minus can attack this phosphine, and Cl will go out as a leaving group. So at this moment, the bond pair or the lone pair can come over here, and this will go out. So that is how phenyl 1-oxo 1-phenyl uh, phospholine is obtained. So just by changing the one letter, instead of if there is a E means there should be a double bond. If there is a means there is no double bond. That's what you need to remember. And in this double bond containing one preparation requires a Diels order kind of pericyclic reaction, and here double bond butadiene is required. In addition to that, dichlorophenyl phosphine is one of the reactant. So let's just by maybe one more method of preparation of 1-chloro 1-oxo phospholine. So here the reactants you can observe. You just look into that. Observe butadiene is common. It's a diene, and here this is the dienophile. What will happen here? So this is dichloroethoxyphosphate. Name of this compound is dichloroethoxyphosphate. What will happen? The lone pair present on the phosphine can attack here, and this bond pair can come over here, and this bond pair form a bond with phosphine. So this is what obtained. And at this moment, the lone pair present on the oxygen itself is involved in a bond formation, and Cl will go out. Here the Cl is the leaving group, and it won't go completely. So again, the Cl minus form a bond with ethyl group. So because there is an involvement of lone pair, so this bond pair, the bond between the oxygen and carbon weaks. So then Cl minus attack the electrophile carbon forming, and here again the leaving group is ethyl chloride. So this bond pair will move here, and sit as a lone pair on the oxygen. So that is how the 1-chloro 1-oxo-phospholine is obtained. Okay. So this is another method of preparation of phosphorines. Okay, more particularly 1-oxo-phospholine. This is also a 1-oxo-phospholine. This also 1-oxo-phospholine. So with this, I will go to the next slide. So next slide, I'm taking past poles. So past poles means if there is a suffix called OLE. OLE means you should write the two double bonds in a 5-membered ring. So how one can prepare this particular phospholine? You know that a di, more particularly what you can say that this is 1 carbon, this is 2, 3, 4, 5, 6, totally 6 carbon atoms are there, but there is a triple bond at second position and fourth position that you have to mention 2 comma 4 hexa diwine. Okay, 2 comma 4 hexa diwine when it is treated with phenyl phosphine. Okay, this is the phenyl phosphine. So what will happen? There will be a reaction. How the reaction? The lone pair or maybe a bond pair can react with this carbon, and this bond will go over there, and this bond form a bond with this. And similarly, you know that here the living groups are proton, that protons are taken by this bond pair. So that means what we can observe here, there will be a new bond formation between this carbon and this phosphine, this carbon and this phosphine. Similarly, there will be a new bond formation between this carbon and proton, this carbon and proton. That is how the dimethyl right. No, I think here I will correct it. Uh, so there is a double bond here. Okay, there is a double bond here. So then only it is phospholine, and there is no double bond here. Okay, this is not there. Okay, you need to account. Okay, so this double bond is not there, but these two are there. How? That means what will happen? There will be a new bond formation between this carbon and phosphine, this carbon and phosphine. Okay, there is no movement. Okay, this bond pair is not going over there. So that means again, this is also I should not mention. So that means only the new bond formation between this carbon and this phosphine, and this carbon and this phosphine. How I can say that? The lone pair present on the phosphine can attack here. Okay, the lone pair present on the phosphine can attack here, and uh, of course this can picks up a proton, this proton. Similarly, the lone pair present on the phosphine or this bond pair can attack phosphine, and H minus and H plus. Yes, that means the two lone pairs. Okay, more particularly phosphine is having a pH bond and pH bond, no? So that pH two bonds are there, no? Two bonds will involve in a bond formation. How? That means pH is the nucleophile. Okay, that means this bond pair attacking here, and this picks up a proton, and again this bond pair attacking here, and this will picks up a proton. That's what there is a double bond here, there is a double bond here. So that is how a 2 comma this is 2 comma 5, 1 2 3 4 5, 2 comma 5 dimethyl 1 phenyl phosphol is obtained. So that means phosphol, it is possible to synthesize starting with the 2,4 diwine when it is treated with phenylphosphine. So here, instead of taking phosphine, it's dibromophosphine is the reactant. And of course, this is instead of taking diwine means sp carbonatum. Here, sp2 hybridized one. That means butadiene is taken. So butadiene, when it is treated with phenyl dibromophosphine. So again, here what is happening? The lone pair present on the phosphorus can attack here, and this bond pair can go over there, and this bond pair can come over here, and Br will go out. So that is what a intermediate form like this. So later on, this bond pair can come over here, and this will go out as a HBr. So this is dehydrohalogenation occurs in presence of base. And you know that there is a double bond here, there is a double bond here. But there is a partially saturated 1H proton is there. So again, in presence of base, okay, the base can obstruct this proton, and this bond pair can come over here, this bond pair can come over here, and this bond pair will sit on a phosphorus, and Br will go out. So that is how 1-phenyl 3,4 dimethyl phosphol is obtained. Okay. So this is about the two methods of preparation of phosphol, starting with butadiene and butadiene, YNE. Okay. With this, I will go to the next slide. So next slide is about the six-membered ring phosphorus containing heterocycle. Six-membered ring phosphorus containing heterocycles. So okay, just I will revise up to this. Maybe what and all we discussed other than the nitrogen, phosphorus, and silicon containing heterocycles. So we discussed about the synthesis of phosphols. We discussed about the synthesis of phospholines. We discussed about the synthesis of phospholanes. Okay, these are the three category of other than nitrogen, sulfur, oxygen containing heterocycles, and their preparations we discussed in this class. Maybe what I will do at this stage, I will stop. Maybe Monday I will continue the next class. Okay. Now I will stop sharing. Okay. Fine. Maybe you can log out.
Thank you, sir.